Okay, next, we are going to think about the J-test, criterion-based test. So, so in the criterion-based test, remember, we will think about unrestricted, um, so let me put it this way. If the null hypothesis, like in general, the unrestricted minimum will be smaller than restricted minimum, because restricted minimum is minimization with constraint, so cannot do as well as the unrestricted minimum. But if the null hypothesis was true, then the unrestricted minimum will be similar to the restricted minimum. Okay, so we are going to test how to do it. So after standardization, after some standardization, we are going to use will follow chi-square 1. Okay, so I remember I put restricted criterion function ahead, like a first, and then subtract the unrestricted criterion function, because we know this is larger, so we have to make it always positive. Chi-square is always positive, so I put it this way. But here, actually, there is another thing I had to mention here. In the previous homework 4, we learned that when x is, if you know x is exogenous, instrumental variable does not matter, right? So in the previous homework, we actually considered like a vector here, not just x itself, but we had to think about, we started from here, and then in the end, we learned that in the end, it does not matter. In the end, the instrument does not matter. And in the end, it is just an OLS estimator. Okay? But now let's think about testing. Okay, we know the conclusion. We know, anyhow, the instrument does not matter. Then the problem is, okay, first let's think about the unrestricted model. In the unrestricted model, we have only one moment condition and one parameter. So in the equilibrium, in the minimum, at the minimum, this will be 0, right? So if you plug this back into this equation, you are going to get 0. So that is nice. In our case, this is always 0, right? By definition, by construction, because there is only one equation which can be satisfied by one parameter. But that is okay in the unrestricted model. But in the restricted model, if you do not use the instrument, then you are in the same situation. You have one restriction with one moment restriction with one parameter. So if you use only one restriction, you are going to get another 0 from the restricted model. This is wrong. It does not work because your test statistic is always 0, which does not make any sense. That's because even if we know that z does not matter in estimation, but we have to revive it for testing, because basic idea is we would like to see how much the moment condition is violated. So we have to allow violation, which is coming from z, right? So you can understand it this way. In the in the in the in this case, in the end, you are going to use like the full weight on only on x, intuitively speaking, to satisfy this one. So satisfying the first moment equation will also minimize the second equation too. That was the solution by the structure, right? But so estimation wise, we can ignore instrument, but now we have to see how much the second moment is close to zero or far from zero. If it is different from zero, then that's when we reject the null hypothesis. Okay. So actually, we have to revive this one. Right? Rewrite this one, and I will not change this part. So because we have done exactly the same problem in homework 4. In homework 4, we learned that how to calculate the optimal weighting matrix, like V prime V, that was a projection matrix. So we derived, in the end, it is an OLS estimator. Okay, so this result does not change, but here we have to start from the very beginning, not the result from homework 4. Okay, so unrestricted criterion function minimum is simple. Now we have to think about uh, restricted minimum. And in this case, we can use, let me see how we do it. 1 second. So you may borrow the result from the previous homework, and I deleted all the things, so I had to rewrite this. So I will copy this guy to here, and the thing here, and so, and remember, in the middle we had some weighting matrix, and remember, the weighting matrix took the form of sigma squared times so let me put it this way: omega inverse, where omega inverse, here you have to put hat, omega was like this. So of course, remember, we are using homoscedasticity assumption. So sigma squared is the conditional variance of epsilon given x and z. And so its estimator will be, excuse me, sorry for changing it too often. Like, up, up. phone. Oh no. Oh no. What happened? What happened? Okay. Oh, I will continue. I'll continue in the next video. I'll come back soon. Sorry.